This is Lab 4.1 Excel, and in this lab we are going to use linear regression to forecast direct labor hours. Now this lab is about a company called Heartwood, and Heartwood uses direct labor hours to apply manufacturing overhead. So the first thing we want to do is go ahead and open up our data. This is Lab 4.1 data. And let's take a look at what we have here. We have 8 years worth of data, and Heartwood is trying to determine whether we can use housing starts, whether they be large multifamily homes, small multifamily homes, or single-family homes, to predict direct labor hours. This would help them in their budgeting process. You will need the analysis tool pack to run this lab, so if you don't have that, you'll need to get that before you start. Now, we can't see all of the data on this page, so one thing I like to do is change the view and freeze the top row so that I can keep track of the column headings when I scroll down. Let's go ahead and run our regression. We're going to go to Data, Data Analysis, start typing in regression till you see it, click Enter. Heartwood wants to examine whether housing starts from the last 3 years, that's X6 through X8, can predict direct labor hours in January of 2009. So let's go down to the last 3 years. Our Y variable, that's our range, our direct labor hours, that's what we're trying to predict here. It's going to go into this input Y range, and the X range is going to be columns B through D of those same rows. And we'll go ahead and click OK. And we've got regression output here. Okay, let's take a look at this regression output. The model is not significant. We have a high p-value here. We've got a negative adjusted R-squared. There's just not a lot going on here. Notice we don't have labels here because of the way the data were set up with us grabbing the bottom of those columns, the last 3 years worth of data. And so since they're not labeled, we just have to refer back to the original data. They will show up in order. The first independent variable is going to be the large multifamily structures, then small, then single family. So X1, X2, X3, that's what those correspond to. So if we had to create an equation to predict direct labor hours, we would say that our direct labor hours are going to be equal to our intercept, 9629, plus 1.51 times our large multifamily homes, minus, because we have a negative, 43.89 times our small multifamily homes or structures, plus 2.41 times our single family homes. But again, we know that this isn't a very good model. And for that reason, Heartwood decides to adjust the model. Managers believe that housing starts are a leading indicator for installation labor hours, meaning that they occur before the labor hours occur. More specifically, managers believe that for Heartwood's jobs, the cabinetry installation doesn't occur in the month of the housing start because that's when the foundation is being poured and some other things are going on in that build. Instead, it occurs in the month following the housing start. So that's a great hypothesis. We have to investigate it. Let's check the data. Let's go back to our original data, and we are going to create a new column, column F, and label it next month direct labor hours. Okay. So the idea is that if we start a home in January of X6, then in February, we will see an increase in the direct labor hours used by Heartwood to install cabinets. So we are going to set cell F61 equal to E62, and we're going to drag that all the way down or just double click it. And so we've effectively shifted this data in column E to column F, but we've delayed it by 1 month. Now let's use regression again to see if housing starts can predict next month's direct labor hours. So we'll go to Data, Data Analysis, Regression, and the Y range is going to be column F now. And for the X range, we're going to grab the corresponding rows in columns B through D. Once we have that in, we'll push OK. Spread this out so we can see it a little better, blow it up. Okay, let's see what we're dealing with here. Now our adjusted R squared is far better. We are explaining some of the variance in Y with our independent variables. We've got a significant model. This is a small p-value, and we have some p-values, at least one here, that seems to be significant. So this seems like a much better model for predicting direct labor hours based on housing starts. And this data, this model can help Heartwood predict how many direct labor hours they will need, which will help them when they're allocating overhead and also when they're planning their direct labor needs for the upcoming months. And this concludes Lab 4.1.